Hello friends, in this video I will discuss about atomic mass unit and mole concept. So let us start. So let us see the definition of an atom. Atom is the smallest particle of an element that do not exist independently but retains all its chemical properties. So then it is known as atom. So example, hydrogen atom, chlorine atom, oxygen atom, like this. Then we have a molecule. So this molecule is nothing but the smallest particle of an element or a compound capable of independent existence under ordinary conditions. Then it is called as molecule. Example, hydrogen molecule, chlorine molecule, oxygen molecule, like this. So then we have different types of molecule like monoatomic molecule like argon, helium, neon, krypton. So then diatomic molecule like hydrogen, oxygen, nitrogen. So then we have a triatomic molecules like ozone. So then we have a tetraatomic molecules like phosphorus, P4. So then we have a octaatomic molecules like sulfur. So then we have a atomicity. The number of atoms in a molecule of an element is known as atomicity. Example, hydrogen, its atomicity is 2. Phosphorus molecule, its atomicity is 4. So like that, oxygen 2 and sulfur it is 8. So then we have a valency. Valency is nothing but the combining capacity of an atom or a radical is called as valency. So example, so if we consider this hydrogen valency is 1. So like that, copper 1 and 2, tin 2 and 4. Right. So we have a chemical formula. So the simplest elements which are present in that particular molecule can be represented with the help of chemical formula. Right. So you can see this one. So we can write the chemical formula for some molecules like hydrogen chloride. So with the help of this one. So first we have to write the symbol, then below we need to write the valency, then we have to crisscross like this, then we can get the formula like this: aluminium, oxygen 3, 2, Al2O3, like this. So here we have a atomic mass. So this atomic mass is based on some standard. So that standard is carbon 12 is considered as a standard. So 1 atomic mass unit is the mass exactly equal to 1/12 of the mass of 1 carbon 12 atom. In other words, 1 AMU is equal to 1.66 into 10 raised to minus 24 gram. So we're going to use this AMU or atomic mass unit as the standard to find atomic mass. Right. So according to that one, so hydrogen atomic mass is 1, carbon 12, nitrogen 14, oxygen 16, chlorine 35.5, oxygen 40. So this AMU is represented with the help of U. So this is like this. 1 AMU is nothing but this quantity, right? So this average atomic mass. So because most of the elements exist as an isotope, so for that reason we're going to consider the average atomic mass instead of this atomic mass directly. So if we consider this chlorine exists as 2 isotopes, one is 35 and second one is 37. So its ratio is 3:1. 3:1. So 75% is 35 and 25% is 37. So for that reason its average atomic mass can be calculated with the help of this one: 35 into 3, 37 into 1. So 3 plus 1 is equals to 4. It will counts to 35.5. So like that we have a relative atomic mass. So this scale is related to this one. So carbon 12 is considered as 12. Hydrogen is equals to 1.008. Lithium 4.003. So like that, helium and lithium, beryllium, like this, right? So then we have this one, molecular mass. So molecular mass is nothing but the sum of atomic masses of all the atoms in a molecule of the substance is known as molecular mass. So we can calculate this molecular mass of HNO3. So with the help of this one, atomic mass of 1 hydrogen is 1, atomic mass of 1 nitrogen is 14, atomic mass of oxygen is 16, but we have a 3. So for that reason, so it will counts to 1 plus 14 plus 48, which is equals to 63 atomic mass unit. So then we have this concept which is known as mole. 1 mole of the means this a mole is a chemist counting unit. So it is equals to 6.023 into 10 raised to 23 number. So that is 1 mole is equal to 6.023 into 10 raised to 23, just like 1 dozen is equal to 12. So how are we going to use this one, that we'll see here. The mass of 1 mole of a substance is equal to its relative atomic mass or molecular mass in grams. In other words, atomic mass of hydrogen is 1 AMU. In other words, gram atomic mass of hydrogen is 1 gram. It means that mass of 1 mole of hydrogen atoms is equal to 1 gram. That is, mass of 6.023 into 10 raised to 23 atoms of hydrogen is equal to 1 gram. So I hope you got this one. So then we have this one. Mole is equal to given mass in grams divided by gram atomic mass for atoms. Mole for molecules, given mass in grams divided by molar mass. So we can calculate that one here. So 52 grams of helium is equal to how many moles? So we know that atomic mass of helium is 4 AMU. So for that reason, given mass in grams is 52 divided by 4, which is equals to 13 moles. So like that we can calculate the same thing for this glucose also. Here find the number of moles present in 540 grams of glucose. So in this case, molar mass of glucose can be calculated with the help of this formula. It will counts to 180 AMU. The number of moles is equal to 540 divided by 180, which is equals to 3 moles. Right? So like that we have one more formula. So percentage composition of a compound. So we're going to consider, or we're going to calculate the percentage composition of a compound for one particular atom. So here in this case, percentage composition for the sodium, mass of sodium divided by molecular mass of that particular compound. So in this case, it is 46 divided by 106 into 100, which is equals to 43.4%. So then we have this one, empirical and molecular formula. So we know that the molecular formula is the exact ratio of atoms of various elements present in one molecule of the compound. So this is known as molecular formula. So like that, empirical formula is nothing but the simplest whole number ratio of various atoms, which are various atoms of elements present in one molecule of the compound, is known as empirical formula. So let us take an example. So here in this case, so if you consider the glucose molecule C6H12O6, in this case, so this itself is its molecular formula, but its empirical formula is CH2O, right? So like that, for hydrogen peroxide, its molecular formula is H2O2, but its empirical formula is HO. So like that, molecular formula is equal to N times empirical formula. So this N is nothing but molecular mass divided by empirical formula mass. So we have one more formula which is related to this one. Molecular mass is equal to 2 times vapor density.